Forest fires burn millions of acres each year in just the US. The causes can be varied: a lightning strike, intentional arson, or something as simple as a person carelessly dropping a lit cigarette. The results are still the same: the loss of approximately 20,000 lives every year, economic losses that are estimated to be up to $350 billion annually in the US alone, and severe damage to the environment. While forest fires cannot be completely eliminated, the ability to predict them can help us effectively manage the fires, thereby minimizing their impact. My name is Reshma Kosaraju, and my project is applying AI to predict the probability of a forest fire occurrence using meteorological data. Artificial intelligence has revolutionized how we solve problems, so I decided to utilize AI for my project as well. I obtained publicly available meteorological data from certain fires that have occurred in the past. I then built a neural network model to predict forest fires using meteorological parameters such as temperature, humidity, soil moisture content, and wind speed. I also included other parameters such as month and day of the week to account for human-caused fires. For example, there is a greater chance of a forest fire occurring over the weekend, as more people go camping during this time. I coded my neural network in Python and used libraries including TensorFlow, Pandas, NumPy, and Keras. My model splits the data into a training set and a testing set. Roughly 80% of the data is used to train the neural network, and the remaining 20% is used to test its predictive power. The model trains and familiarizes itself with the data through neurons in the layers of the neural network, as well as epochs, which are how many times the data is fed to the model. I experimented to determine the optimal number of neurons, hidden layers, and epochs. My neural network has 4 layers in all. The input layer has 6 neurons for the 6 parameters, plus 1 bias neuron for 7 total neurons. The first hidden layer has 64 neurons, and the second one has 32. The output layer has 2 neurons for the binary classification as 1 being a fire and 0 being no fire. Here is how the model runs. The user must input the required values for the different parameters used in the model. For example, if I enter in random values for each parameter that are very conducive to a fire starting, the probability will be high. For the month, I will enter August and Saturday for the day of the week. For temperature, I'll enter 32 degrees Celsius with a relative humidity of 2%. For wind speed, I'll do 23.8 kilometers per hour and 0 millimeters per meter squared for rain, which is the soil moisture content. After pressing enter, the model will output a prediction of the probability of a fire occurring within a couple of minutes. The model outputs both the probability and a binary class for easy interpretability. As you can see here, the probability is very high. Through extensive development and experimentation, I was able to achieve a true positive rate of 89%, which means that my model can predict 89% of all forest fires. The global training accuracy of the model was over 85%, and the global testing accuracy was over 70%. My model has the capability to save countless lives and billions of dollars annually. It can also help reduce pollution and slow climate change, and can even prevent other natural disasters such as mudslides that are caused by the loss of vegetation. In summary, my model has the potential for large societal impact.